The shifting rock in an earthquake causes vibrations, called seismic waves, that travel within Earth, or along its surface. Whenever large-scale events like volcanoes, earthquakes, and explosions occur, they produce waves that spread out in every direction and travel through the different layers of the Earth. Seismologists can detect the waves, using devices called seismometer, and used a seismograph to record data about seismic waves. This yields information that can help scientists learn, not only about earthquake behavior, but also about the structure of Earth itself. There are two broad classes of seismic waves: body waves and surface waves. Body waves are waves that travel through the Earth's inner layer, and while surface waves are waves that can only travel through the surface layer. The body waves travel faster than the surface waves. However, surface waves causes more damage than the body waves. Now, there are two types of body waves: primary waves and secondary wave. P waves cause the ground to compress and expand, which move back and forth in the direction of travel. They're called primary wave because it is the first waves to arrive at seismic recording station. S waves shake the ground in a shearing or crosswise motion that is perpendicular to the direction of travel, and called secondary waves because they always arrive after P waves and only get through solid materials. They are followed by surface waves, which travel along Earth's surface. Surface waves travel only through solid media. They are slower moving than body waves, but are much larger and more destructive, and also have two types. The first one is love waves, which moves the surface side to side at a right angle to the direction of the wave. The second one is Rayleigh waves, which moves the surface in a rolling circular motion. When seismic waves reach a boundary between two different mediums, they can be reflected, absorbed and refracted, which means that they change direction. And remember, when refraction happens, it is because the waves change speed in mediums of different densities. At boundaries, between the mantle and the liquid outer core, there's a sudden change in density. And so there's also going to be sudden change in the direction of the wave. Because of the liquid outer core itself isn't all the same density as waves pass through it, they're constantly being refracted, and it's curved because the slowly change of direction. The same thing happened to the mantle, which also isn't the same density. And so again, the waves refracted curvely back to the surface. This diagram is only true for P waves. Otherwise, S waves can only be able to pass like this, because they cannot go through the liquid outer core. S waves couldn't be detected in any of this region, whereas P waves are detected almost everywhere except for this position. Thank you.